Yes, hello everyone. So basically, this is revision session as well as you can say backup also, right? Those who are new, those who have already, like those who have joined late, you can refer these videos for preparation of the important topics which you have missed, right? Remaining topic mostly I will be covering again with the respective chapter. Say the graphical part, I'll try to create a graphical part also, but that in function chapter also again we are going to study. But for the time being, this is very important topic which some individual missed, some individuals are not comfortable with for the time being. So you people can go through this particular video, and at the end of the video I'll be adding some questions also. You people can try those questions, you can ask me later on, right? Okay, so let's get started. Very important topic which we are naming it as inequality and wavy curve method, right? To solve some polynomial by polynomial inequality we are going to use. Now, before entering into it, we require some basic information, that is, just a second. Yeah. So before entering into the chapter, we require some basic information, that is starting with brackets. Okay. You people will be also, where I'll be adding some question. You people can pause the video and solve the question by yourself. Then you can continue with the video lecture over there particularly. Yes, yes. Starting with the first topic of the discussion, that is brackets. Basically, we are going to deal with majorly three types of brackets. Curly braces. Yes, we are calling it as curly braces or curly brackets. Yes, then we'll be having small bracket. Small bracket. Yes, we are also calling it as open bracket. Open bracket. Then we'll be having, yes, closed brackets, right? Or we are calling it as square bracket. Square bracket or closed bracket. Yes, and then we are having at the end, that is semi-open, semi-closed. But this is mixture of these two, either this type or we'll be having closed from this side, open from the other side. So we'll be calling it as semi-open, semi-closed, right? Semi-open, semi-closed bracket will be there. Now what their meanings are, that we are going to study using some diagrams as well as sets. Yes, people, everyone, focus. So basically four type of brackets. This notes also I'll be sharing on the group. There is no problem with that for the time being. No need to write, but try to understand each and everything. Afterwards, you can make your own notes, right? By referring these particular slides. Okay. Then, so what is all these brackets stands for? Say, if I'm telling like set of all values of x satisfying x square minus 5x plus 6 equal to 0. Okay, sir, for this equation we are knowing x square minus 5x plus 6 equal to 0. We can easily say x square minus 3x minus 2x plus 6 equal to 0, or else x minus 3 into x minus 2 equal to 0. So there are only two values of x which are satisfying this equation. So whenever we are having some particular amount of values, particular means some finite values, 1, 2, 3, 10, 15, 20, right? So only those values, if we want to write it in some set form, so what I'll be using, I'll be writing curly braces 2 and 3. This set A, it is set of all the values which is satisfying this. So only we will be discussing the values as 2 and 3. We are not discussing any value between 2 and 3, because any value between 2 and 3, that is not going to satisfy. But exactly 2 and exactly 3, it is satisfying. That means this curly braces indices or indicates, curly braces indicates basically the entries which inside the set, then only will be our answer, right? So entries inside the set will be giving us our answer. That is what curly braces indicates. Yes, next. So now we'll be talking about small bracket. Small bracket, okay. Now you people will be helping me out. Say, let's say we are having this number line. Yes. If I'm telling x is greater than 2 and less than 5, what are the possible x values? 3, 4, that's it. No, actually we'll be having infinite x values satisfying 2.1, 2.2, 2.3, right? Let's say if I'm writing 2 here, if I'm writing here, sir, x equal to 2? No, x equal to 2 is not our answer. Why? Because strictly greater than 2. X equal to 5? No, x equal to 5 is also not our answer. That means, sir, all the values between 2 to 5 on the number line, infinite values we are having between 2 to 5 on the number line, right? So in that case, we can say, sir, x, this symbol, it is belongs to. So x belongs to open interval 2 to 5. That means infinite values between 2 and 5, any value x can be. But it cannot be equal to 2, it cannot be equal to 5 because strict inequality is there. They are telling like x is strictly greater than 2 and strictly lesser than 5. Okay, so sir, that means small bracket, what it is representing on the number line. On the number line, let's say they are telling like x is between a to b. Sir, why you are making whole here? That is a is not included, b is also not included in the answer. So in that case, I will be telling like x belongs to open interval a to b. X can be any value between a to b, but it cannot be equal to a, cannot be equal to b. Right? It can be 4.99999, yes, but it cannot be exactly 5. So any of the infinite values between 2 to 5 it can be, right? So a small bracket represent the boundary values are not included. Just lesser than boundary value here or just greater than boundary value here, that is included for sure. Yes, in inequality form we'll be writing it as x greater than a and less than b. Likewise I'll be writing. And this is what we are having representation on the number line. Clear? Yes, third one, closed bracket. Closed bracket. So same example. If I'm taking x greater than equal to 2, less than equal to 5. That means x now, sir, all the infinite values between 2 to 5, they are correct, right? But sir, 2 can be also our answer or 5 can be also our answer, right? Any answer between 2 to 5, that will be okay. But still, now sir, boundary values are also included in that case. So what you will be telling like, yes, this is small bracket or open bracket also we are naming it as, okay? Open bracket. Yes, small bracket we are naming it as open bracket. Yes. Square bracket or close bracket. Let me know. Now I guess you people understood. Yes. Closed bracket. Just a second, let me check. Yep, done. Okay, closed bracket. Now everyone tell me, sir, here we can say if they are telling like x belongs to closed a to b. So look, whenever boundary values are included, on those boundary values I'll be using dot, right? If it is not included, I'll be using holes, right? Holes likewise. So here if I'm using dot means x belongs to what? Closed interval a to b, right? That a and b are also included. Or clearly you can say x is greater than equal to a and less than equal to b. That is what it is representing over there, right? I hope you understood what exactly small bracket and closed bracket refers to. Okay. Sir, then we are having semi-open, semi-closed. What it is? Semi-open, semi-closed. We'll see. By the name itself, I guess it is clear to you, right? Semi-open, semi-closed. From one side it is open, from the other side it is closed. So say for example, the same example, we are having x greater than 2 but less than equal to 5. What you will be telling like, sir, on the number line, we'll be having at 2 we'll be having whole, but at 5 we'll be having dot. That means 2 is not included but 5 is included, and all the values between 2 to 5 is our answer. We can simply say x belongs to open interval 2 to close interval 5, right? This is another sort of representation we are having. So here clearly we can say, yes, if they are telling like, yes, b here. So in that case, what you will be telling like x belongs to open interval a to close interval b, right? Or else, if they are giving this scenario, here dot and on the b we are having open. So a to b, you will be telling like x belongs to closed a to open b, right? That is what we are going to get it over here. Till here, I hope no one is having any doubt, because these are the basics of this chapter, right? Okay, next. Yes. Now we are moving into union and intersection of two sets. Intersection of sets, basically not necessarily two set, will be having multiple sets also. We will be taking union and their intersection. Now union basically representing addition of two sets, and the intersection is basically representing common part of two sets. How? We'll see. Look, basically we are having two symbols. If I'm starting with union, yes, now no language required for obvious reason, right? We are not preparing for some theory examination. So directly, basically whenever we are representing union, union symbol will be given by U. Okay, we'll be having some U symbol to represent union. Now what exactly union is? Say for example, we are having A as some set 1 2 3 4 5 6, and set B, let's say set B we are having it as 4 5 9 11 12. Now, if they are asking A union B, A union B a set where all the elements of A will be there, also all the elements of B will be there. That means we'll be having 1, 2, 3, 4, 5, 6. With that we'll be having 4, 5. Look, 4, 5 we have already entered here. Then we need to enter 9, 11, 12. So this A union B is nothing but a set of which A will be also there and B will be also there, right? That is what we are calling it as A union B. Okay, that means we'll draw the Venn diagram. See, what is Venn diagram? Basically we'll be having some rectangle. Inside the rectangle we'll be drawing some circles. These circles are representing the given sets, let's say, right? Given set. Common part we are knowing it is 4 and 5, so I'll be writing here. Then so 1 2 3 6, that will be in A alone. Now tell me, what is B? 4 5 we have already written, 9 11 12. So this is what we are having, all the elements of B. Now what is A union B represent? A union B represents this entire area. All the elements in this area, if I'm writing together, will be getting A union. Now, so what is intersection then? Yes, intersection, everyone try and understand. Look, intersection we will be using symbol as inverted U. Now what it is? The same sets, let's say we are taking A is equal to 1 2 3 4 5 6, right? B is equal to 4 5 9 11 12. Now if I'm talking about A intersection B, it will be representing common element of A and B, or common part of A and B. What is common part of A and B, which are in both? That is 4 and 5. This is A intersection B. Sir, Venn diagram. Yes, so we are having, let's say, these two circle as A and B. Here we are having 4 5, right? Remaining element it is as it is, which we have written earlier, right? So this area, it is basically, or all the element in this part, they will be representing A intersection B. Is that clear? We are naming it as Venn diagram basically. Okay. Yes, but sir, are we going to take union and intersection likewise only for the bigger set or the infinite set? I'll say no. Yes, we'll draw the number line mostly in order to find out intersection and union. Say, all of you, I'm taking some example. Say this time, let's say we are having set A as let's say we are having x belongs to 2 to infinity and x belongs to minus infinity to 5, right? Okay, we are interested in, let's say this is set A and this is set B. Now we are interested in A union B and A intersection B. Okay, common part of these two and basically the union of these two. So for that purpose, what we can do, we can use two things. Yes, now all of you, whenever I'll be drawing number line, first set they are telling like x is from 2 to infinity. Let's say 2 is somewhere over here. 2 to infinity means right side of 2 or left side of 2. At 2 we are having close. Look, at infinity and minus infinity will be always keeping open bracket, because These boundary values we cannot include. Infinity is not defined, right? So these boundary values we cannot include. Now 2 to infinity means we will be having this area of the number line, right? 2 to infinity, up to infinity. Yes. Secondly, they are telling like minus infinity. We are knowing minus infinity on this side. Minus infinity to 5. 5 also close. This is set B. Okay. Now, sir, this is what we are having. This black area, it is represented by the second graph. Now, if they are telling like what is A union B? A union B. We are knowing entire number line is covered. So A union B is all real number. Are yes or no? All real number, that is entire number line is covered. Okay, what is A intersection B in this case? A intersection B, what is common part of these two? Sir, 2 to 5 it is there in the first set as well, and 2 to 5 it is there in the second set as well. So this is the common part. A intersection B will be what? Close T2 to close 5. This is what we are going to get over here, isn't it? Yes, I hope till here no doubt. Can we move ahead? Sir, another example. Let's say we are having set A. It is representing x belongs to minus infinity to minus 2. Set B, it is representing x belongs to minus 1 to 0. And set C, it is representing x belongs to let's say minus 3 to plus 3 to infinity, let's say. Okay, so we need to take union of all these. What I'll be getting on the number line if I'm plotting the graph, we'll be getting minus 2 here. So this is what we are having first part. Second part, all of you, minus 1 to 0. Minus 1 here, 0 here. 0 open, right? 0 we are having open. Third part, everyone. Third part, what we are having? 3 to infinity. Yes, 3 to infinity. This is what we are having. Now let me know what is common part between all the three. No common part. So you can say A intersection B intersection C. Basically they're all common part is nothing, null set. We are telling it's 5. What is union of these three? A union B union C. We need to add all the three sets. So we'll be getting what? Minus infinity to minus 2 union. What I'll be getting? Minus 1 to 0 open union. We'll be marking it as 3 to infinity. Yes, this is what we are having answer for union, and this is what we are having answer for intersection. There is nothing in common in all three, right? All three, they are not having anything in common altogether. So that's why we'll be telling like intersection is 5 and union is combination of all the three sets over there. Isn't it? Yes. So that is what we are having the knowledge of. With the question we will be using multiple number of times, you people will be getting comfortable, right? Okay. Now we are moving into inequalities, right? These are basics you must know before we are entering into inequalities, right? Inequalities, very, very, very important topic, I must say. Look, direct question they are not asking in JEE Mains, JEE Advanced, but in every question mostly once it will be used, right? Almost 90% of the question in JEE Advanced, they will be at least once they will be using inequality over there, right? And for every day, whatever we are going to study, for obvious reason, we are also going to practice inequality in multiple number of questions over there. So important topic from that perspective, right? Inequalities we are moving into. Okay. Starting with linear inequalities. Yes, linear inequalities. Look, we'll study linear inequality, quadratic inequality, polynomial inequality, polynomial by polynomial inequality. Then we'll study logarithmic inequality. Then for every function, mostly greatest integer function, fractional part function, and exponential function. For every function, we'll try to apply inequalities into it, right? So gradually we'll increase the level over there, right? Starting with linear inequality. Say, if I'm telling you x minus 2, no theory, right? Maths means there is very less theory, right? We will be having application part. X minus 2 greater than 0, let's say we are having, right? Or else before that some rules we are going to study. Try and understand. Before linear inequalities we are writing certain rules. For that purpose you people try to understand. Say we are having 10, 15. For obvious reason, which one is greater? 15 is greater. This symbol I guess you people are comfortable with, right? 10 is less than 15. This how I'll be reading it as. Okay, if I'm adding 20 in each side, what I'll be getting? let's say plus 20 in each side, what I'll be getting? 30 here, 35 here. Again, this is greater, right? If I'm subtracting, let's say 100 out of it, yes. So what I'll be getting? Minus 70 and minus 65. Which one is greater? For obvious reason, this is greater, right? Minus 100 we have done. Okay. If I'm multiplying by 2, let's say, multiplied by 2, minus 140, minus 130. For obvious reason, minus 130 is greater. If I'm dividing it by 5, let's say, dividing it by 5, what I'll be getting? Tell me. Minus 140 by 5, that is 2, minus 2, then we are having 40, minus 28, and here we'll be getting minus 26. So again, minus 26 is greater, right? Look, addition, subtraction, multiplication by positive number, division by positive number, inequality orientation still be intact. It is not reversing. Yes, but sir, let's say if I'm multiplying it by minus 2 now. If I'm multiplying it by minus 2, everyone, minus 28 into minus 2, tell me, 56, and here we'll be getting minus 26 into minus 2, 52. Sir, now 56 is greater. That means whenever we are multiplying by a negative value, the inequality orientation will reverse. Yes, okay. So let's say if I'm dividing it by 4 or minus 4, if I'm dividing it with. So what I'll be getting? If I'm dividing it by minus 4, we'll be getting what? Or else divide by, instead of minus 4, let's say we are doing something which is common into it. So let's say, yeah, let it be minus 4. So from minus 4, if I'm dividing, what I'll be getting? 14. In fact, minus 14. Here we'll be getting minus 13. Again, minus 13 is greater. That means you people can say division and multiplication by negative value will reverse the inequality orientation. Addition, subtraction won't make any changes in the inequality orientation. Multiplication by positive and division by positive numbers doesn't change the inequality orientation. When it will be changing? When if we are multiplying by negative number or dividing by negative number. First thing. Secondly, yes. So this is what we are having. We will be writing it in the notes. Yes. Addition, subtraction, of any number on both the side of inequality, doesn't changes inequality orientation. Okay. Secondly, multiplication, division by positive numbers, inequality orientation remains same. Okay, I'm writing same orientation, it is not changing. Yes, but multiplication or division by negative numbers, orientation will be reversed. Yes, it will be changing and it will reverse, right? Is that clear? Yes. So these are the basic rules we are having. Okay, so few more things we are going to study with that. Yes, you people help me out here. Let's say we are having 2 and 4. Which one is greater? 4, right? So for obvious reason, what I can say, if I'm squaring both the side, 4 here and here we'll be getting 16. Still we'll have the same relation. But so minus 2 and 1, which one is greater? 1. But if I'm squaring this time, here we'll be getting 4, here we'll be getting 1. Reverse. Right? Okay, sir, if we are having minus 4, minus 2, right? This one is greater. If squaring will be giving us what? 16 and 4, right? Reversed. That means squaring is only possible if both the sides are positive. If one side is positive, one is negative, or one side is both the sides are negative, in that case squaring is problematic, right? So squaring can be done if both sides are positive, right? Then only we can do squaring. Otherwise squaring will change our answers in that case, right? So these are the basic rules you need to follow while solving inequalities, right? Okay, next you people try to understand. This is basically, now we are moving into inequalities, right? Typical inequalities. Let's say we are starting with linear inequality. Okay, linear inequality. Yes, you people help me here. Say for example, if we are having x minus 3 greater than 0. Now what I am doing, sir, we are knowing some basic rules. If I am adding 3 on each side, inequality orientation won't be changing because addition, subtraction. Sir, why you are doing so? Because let's say we need to find out x values, right, which are going to satisfy this inequation. So if I am adding 3 on each side, we'll get x here, we'll get 3 here. That means x greater than 3. On the number line, what I'll be saying, sir, 3 here, open because equality symbol is not there. Then greater than 3 means in the right side of 3 they are asking all the values. So x can be any value from open 3 to infinity, isn't it? Yes. Another example, if we are having 2x plus 5 less than 0. Sir, let's say we are starting with, sir, first of all, to isolate x, we are subtracting minus 5 from each side. We are subtracting 5 from each side. What I'll be getting here? 2x less than minus 5. You can say 5 I have taken on the other side. That is also okay, right? But at the same thing, I'm subtracting 5 out of it. Now if I'm dividing it by 2, dividing by 2. Now 2 is positive number or negative number? Positive number, inequality orientation will remain same, will get minus 5 by 2. On the number line, let's say I have plotted minus 5 by 2. X is less than minus 5 by 2. So x value will be in the left side or right side? In the left side of minus 5 by 2. That means, sir, from minus infinity to minus 5 by 2, x can be any value. So x belongs to minus infinity to minus 5 by 2. Minus 5 by 2 open. Why? Because equality symbol is not there. Yes, same goes. We are having 3x plus 12 greater than equal to 0. Okay, some easy questions. Quickly we are picking it up. So if I'm subtracting 12 out of it, we'll get 3x greater than equal to minus 12. Yes, subtraction and addition does not change inequality orientation. Now if I'm dividing it by 3, what I'll be getting? Tell me. X greater than equal to minus 4. On the number line, I'll be plotting minus 4. Sir, minus 4 I'll be plotting with dot. Why so? Equality symbol is there. X can be equal to 4 also. In that case, sir, you will be telling like in the right side of minus 4. That means x belongs to minus 4 to infinity. Yes, infinity always open interval, and minus 4 equality symbol is there. That's why we are picking close interval there. Understood? Yes? This is what we are having. Next. These are very basics, right? Sir, if we are having, let's say, 7 minus 5x less than 0. Okay. So, sir, let's say starting with, we are interested in isolating x. So, if I'm subtracting 7 from each side, what I'll be getting? Minus 5x less than minus 7. But, sir, now we need to divide by minus 5. Minus 5 we need to divide with. If I'm dividing with minus 5, here we'll get x, here we'll get 7 by 5. But, sir, the moment we have divided it by negative value, the inequality orientation will reverse. So, here what I'll be getting basically, sir, 7 by 5, from 7 by 5 to infinity will be the answer, because they are telling like x is greater than 7 by 5. So, in the right side of 7 by 5. So, answer will be x belongs to 7 by 5 to infinity. I hope basics you can abstract now. Right? X can be any value from 7 by 5 to infinity. Yes? So, this is what we are having, linear inequality solution. For obvious reason, it is not enough for us. So, starting with quadratic inequality. Okay. Quadratic inequality means it will be having two factors. Till now we are having only one factor. Okay. Yes, here you need to pick two words. So whenever we'll be calling for and A and B means we will be taking intersection of and will represent intersection of two sets. If I'm taking A or B, either A or B, so we need to take answer from A or B. That means we need to take union of two sets in that case, or union of multiple sets. Whenever word keyword or will be there, we'll take union, and whenever we'll be having keyword as and, we will be taking intersection of the sets over there. Sir, how does it help? We'll see with the question. Yes, try and understand. Yes. Okay. Let's say we are having x minus 2 into x minus 5 greater than 0. Okay, this is some inequality you need to solve, that all the values of x for which then this inequality will be satisfying, right? Sir, we'll see x belongs to what they're asking. Sir, if I'm putting x equal to, let's say, 7, everyone tell me, 7 minus 2, 7 minus 2 positive, 7 minus 5 positive, positive into positive, yes, they are going to satisfy. So there will be multiple number of, say if I'm putting x equal to 4, 4 minus 2 positive, but 4 minus 5 negative, positive into negative will get negative, so that those x value, it is not satisfying this inequality. So sir, for that purpose, what we need to do? Okay, now if I'm telling you product of two numbers is positive, product of two numbers or two things are positive, when it is possible, either both are positive or both are negative. Tell me, yes or no? Yes. So sir, here we need to form some cases. Case 1, either x minus 2 greater than 0 and x minus 5 greater than 0, both are positive, or look, in between these two we are having and, or case 2, that is x minus 2 negative and x minus 5 negative. If both are negative or both are positive, in both the cases we will be getting this product as positive, isn't it? Yes. So sir, here if I'm solving two linear factors, x minus 2 greater than 0, x minus 2 greater than 0 means x greater than 2, x minus 5 greater than 0, that means x greater than 5. In between we are having and, we need to take common part. X greater than 2 means in the right side of 2, x greater than 5 means in the right side of the 5. In between and means we need to take the common part, which is x belongs to 5 to infinity, or greater than 5 basically, right? Clearly it is visible. Okay, now sir, in this case, case 2, x less than 2, x less than 5, we need to take and in between, means common part of these two. On the number line, what I'll be having? 2, 5. X less than 2, x less than 5. What is the common part? This common part, that means x belongs to minus infinity to 2. Okay. In between these two cases, what we are having? Or, either case 1 or case 2, right? So we need to take union of these two, all of you. What is union of these two? Combine D. Let's say another number line if I'm drawing. First, second one is telling minus infinity to 2, and first one is telling 5 to infinity. What is the union of these two? X belongs to minus infinity to 2 union 5 to infinity. This is what we are going to get the answer. Yes or no? Correct? That is how we are going to solve quadratic inequality. For obvious reason, these long methods we are not going to use, but basics are these things, right? Sir, but if we are in the same question, x minus 2 into x minus 5, if they are asking less than 0, in that case, sir, in that case, positive, negative, negative, positive, these cases we need to take. Yes or no? Okay, so for that purpose, everyone tell me what I'll be having. Sir, case 1, that is x minus 2 positive and x minus 5 negative, or case 2, tell me what it will be. X minus 2 negative and x minus 5 positive. So that product will be negative ultimately, right? Less than 0 means negative. So how it is possible? What I'll be doing? We'll be doing x minus 2. X or minus 2 is greater than 0 means x greater than 2. Yes, here we'll be getting x greater than 2. Here we'll be getting x less than 5. In between we are having and, means we need to take common part. First one is telling like x is greater than 2. Second one is telling x less than 5. What is the common part? X belongs to 2 to 5. Yes. Okay. So then x minus 2 less than 0, x minus 5 greater than 0. In that case, we can say x less than 2 and x greater than 5. Okay, sir, x less than 2. Less than 2 means in the left side of 2. X greater than 5 means in the right side of 5. Right? In between we are having and, means we need to take common part. There is no common part as such. X belongs to 5. Now, or in between, that means we need to take union of these two. Sir, here it is null set, so combined union will be ultimately 2 to 5 only. Isn't it? Okay, so sir, here comes a new story. Basically, sir, what we are having in this question, x minus 2, x minus 5 greater than 0. So direct answer was what? X belongs to minus infinity to 2 union 5 to infinity. Yes or no? Sir, if they are asking x minus 2, x minus 5 less than 0, x belongs to what? 2 to 5 will be getting the remaining portion of the number line. Okay, sir, why not we make a generalized picture of quadratic inequalities in that case? If we are having quadratic, we can factorize in the form of x minus a, x minus b, right? And let's say a is smaller, b is greater, a is less than b. Okay, in that case, if they are asking greater than 0, what I'll be doing? Directly answer will be x belongs to minus infinity to a union b to infinity. Right? So equality symbol is not there. If it is there, we'll be using close bracket at a and b. Okay. If they are asking x minus a into x minus b less than 0, directly we'll be answering x belongs to a to b. Right? So these are the direct answers we will be using for quadratic inequation. First of all, we'll be converting them into factor form of x minus a, x minus b, and then if they are asking greater than 0, means directly I'll answer minus infinity to a union b to infinity, provided a is less than b, right? And if they are asking less than 0, means I'll be directly answering x belongs to a to b. Done? That is what we are having quadratic inequality. Sir, what if they are asking three factors together, x minus 2, x minus 3, x minus 4 greater than 0? The inequality which is, or the x values which are satisfying this inequality. Sir, product of three things are positive. That means all three are positive, or else negative, negative, positive, or else negative, positive, negative, or else positive, negative, negative. Yes. So these four cases we need to solve. And for obvious reason, we are not having entire day if they are asking 5 boxes, right? So for that purpose, we have derived one method. We are naming it as Wavy curve method. Look, this is Wavy curve method. Some standard definitions are there, but that standard definition I have some modification I have done according to me, so that it becomes student friendly, right? आपको easily समझ में आए, and then you can easily apply the things over there, right? So student friendly will be making it as, okay. So what is Wavy curve method? To solve inequality of type x minus a1 to the power b1, x minus a2 to the power b2, and so on up to x minus an, yes, x minus an to the power bn, divided by x minus c1 to the power d1, x minus c2 to the power d2, and so on up to x minus cm to the power dm, yes, greater than, less than, equal to 0. If these type of inequality is there, we are using Wavy curve method. Polynomial by polynomial inequality we are solving using Wavy curve method. Now what exactly Wavy curve method is? First of all, we'll write the steps. With the question, I will be explaining step by step, right? Step 1. Find zeros. Yes, zeros means where numerator is equal to 0, or x values where numerator equal to 0, and poles where denominator equal to 0, x values where denominator is equal to 0. Clearly you can see here x equal to a1, if I'm putting it is the numerator will become 0. So zeros are a1, a2, a3, an, right? Poles are c1, c2, c3, and so on up to cn, right? So those are zeros and poles we are having, right? Here we are having a1, a2, and so on up to an. Here we are having c1, c2, and so on up to cn. These are zeros and poles we are having. Step 2. Yes. Plot all zeros and poles on a number line. On a number line in order. Now, order means, for obvious reason, you are knowing on the number line after 2 we'll be having 3 only, right? Yes, you cannot place 3 before 2, right? Number line you people are very much aware about. Next, step 3. Step 3. Yes. Mark alternative. Look, bacha, look here, you keep it in mind, we are having x minus a1, x minus a2. Do not make it as a2 minus x. If it is a2 minus x, some different answer will be getting. Sir, if it is a2 minus x, we'll try to make it as x minus a2 somehow by taking minus common or by multiplying by minus, right? But in this standard form, we need to convert first of all in order to solve the question, right? Yes. So mark alternative. That's what I have done to make it student friendly so that they won't be confusing. We'll make it a unified solution over there. Yes. Mark alternative plus and minus sign in each interval from extreme right. From extreme right. Okay. But do not change the sign. Not change the sign at points whose factor having even power. What it is, I'll explain later on, right? Even power or even exponent. Okay. With the question, I'll explain. Next, step 4. Step 4. Yes. Now, positive sign gives solution set of greater than 0 inequality. Yes. Step and negative sign gives solution set of less than 0 inequality. Yes. Okay. And one last note point is there. But chalo, those who want to copy the notes from here, they can do one thing. Simply you can pause the video and copy the notes accordingly, right? Yes. Note point. Note point is include zeros in the answer. Look, student friendly language. This language you won't be finding in the books, right? You cannot come to me and ask, sir, in books it is written likewise. Yes, this is some student friendly language. I'm writing it over there. Include zeros in the answer if equality holds. If equality symbol is there, I will include zeros. Never include poles in the answer. Now what it is, I'll come to this particular part also. Poles in the answer. Yes. Okay, sir. What does it mean? Now we'll start with the very first question which we have solved till now. That is, so we have solved x minus 2 into x minus 5 greater than 0, let's say, right? Okay. Now all of you, what are the zeros? I'll start with step 1. Find zeros. Yes, find zeros and poles. So zeros and poles we need to find out. Zeros means all the x value where numerator equal to 0. So those x values are 2 and 5. So poles we are not having any because in the denominator we are not having anything, right? Second step, plot them on number line. We have plotted them on number line. Now number line is divided into 3 parts. One is this part which is 5 to infinity, 2 to 5 and then minus infinity to 2. So these 3 parts we have done for the number line. Now from extreme right, first part I'll be writing plus, minus, plus. Now plus sign will be giving answer for greater than 0 inequality. Means plus sign means positive, negative means below curve, positive means above curve, right? So plus sign will be giving us answer for greater than 0 inequality. Means for greater than 0, x belongs to what? Minus infinity to minus 2. Union will be getting 5 to infinity. Right? If they are asking x minus 2, x minus 5 less than 0. So negative sign will be giving us answer for less than 0 inequality. Means negative sign, which interval we are having? From 2 to 5. So directly I will be answering x belongs to 2 to 5. And that is what we have done, right? That is what we have done here also. Correct? Okay. सर थोड़ा सा अच्छा क्वेश्चन लेते हैं हम लोग, थोड़ा सा इंक्रीज करते हैं लेवल. Yes, say for example we are having x minus 2, x minus 5 by x plus 7 greater than 0. Okay. Now we need to find out x values satisfying this inequality. Same, zeros will be calculating. Tell me what are the zeros? Yes, 2, 5. And what is the pole? Pole, it is minus 7. Yes or no? Plot them on number line. What I'll be plotting in the extreme right or left? Minus 7, then 2, then 5. Yes, from the extreme right we'll start with plus, minus, plus, minus. Plus means above curve, below curve, above curve, below curve. Look, this wavy curve method is very useful. Plotting the graphs also of multiple number of functions, right? We'll be using very effectively in the upcoming sessions after 2-3 months, right? Keep it in mind. Now, sir, they are asking greater than 0 means they are asking positive sign or negative sign? Positive sign. That means positive sign we are having from minus 7 to 2 union 5 to infinity. Now, sir, equality symbol is not there, so we'll be having open interval throughout. This is what we are going to get the answer. Is that clear? Yes or no? With questions, we'll try to explore new things over there, right? Every question, we'll try to explore some new thing. Now, yes, you can pause the video if you want to solve the question. X minus 2, x plus 7 divided by x minus 3, x minus 4. This time we are having greater than or equal to 0. Okay. So same process will be following zeros. Zeros, tell me. What are having zeros? 2 and minus 7. Poles, we are having 3 and 4. Okay. So in that case, if I'm plotting the number line, from the extreme left we'll be having minus 7, 2, 3, 4. So number line divided in few parts. Those few parts plus, minus, plus, minus, plus. Plus means above curve, below curve, above curve, below curve, and then above curve, right? This is what we'll be having it over here. Send it. Now you people help me out here. So, sir, they are asking greater than or equal to 0. Okay, greater than means we need to answer plus sign. Plus sign we are having from minus infinity to minus 7, union 2 to 3, union 4 to infinity. So now equality symbol is there. So boundary values we need to include. So if I'm putting x equal to 2, numerator will become 2 minus 2, 0, 0 multiplied by something, 0. So equality holds here. Array 0 is equal to 0, right? So 2 we need to include in the answer. What about minus 7? Minus 7 if I'm putting, sir, this is 0. 0 multiplied by something, everything is 0. Minus 7 also we need to include in the answer because equality holds. Yes. But sir, if I'm taking 3 in the answer, if I'm taking 3, so denominator will become 0. So something by 0 is not defined, right? That is not equal to 0. It is not defined, right? That means x we cannot take 3 and also x we cannot take 4. So at 3 and 4, we are not including poles in the answer, but zeros can be included if equality symbol is there. That is what we are having note point. Include zeros in the answer if equality holds. But if equality is not there, do not include zeros as well as poles. And poles we cannot include ever in the answers over there. I hope till here it is clear. Right? Now, sir, this do not change the sign of points whose factor having even power. So this we haven't used till now. We'll try to solve use it in the next problem. See. Okay. Say we are having x minus 5 to the power 101, x minus 3 by 2 to the power 202, x minus 8 divided by x to the power 100 is greater than or equal to 0. Let's say this is what we are having. Okay, so same step, zeros. Look, only basic difference we need to change, basic things we need to change, right? That we have already written. 5, 3 by 2, 8. From poles we are getting x equal to 0, right? 0. Okay, we'll see. Now, sir, whenever we are having even power we are having at 3 by 2, so mark star at 3 by 2. Even power we are having at 0, so mark star at 0. Now you plot them on number line, right? The only basic changes you need to do so that you won't be making any error. Yes, here I'll be plotting 0, then we'll be having 3 by 2, then we'll be having 5, then we'll be having 8. Okay, at 3 by 2 and 0 we are having star. From extreme right, plus, minus, plus, 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 isn't it? Right? Whenever we are having star, do not change the sign. Yes, that is what we have written over there. Do not change the sign of points whose factor having even power. So whenever we are having even powers, right, we have mark their star so that we won't be changing the sign. At 3 by 2 we are having even powers, so plus it will remain. In the next set also it is plus. Here also we are having stars, so next set also it will be plus. Okay, we won't be changing the sign. Sir, why it is so? Let us wrap this question and then I'll explain also why we are taking that way. Now sir, they are asking greater than 0. Greater than 0 means we need to take plus part. So minus infinity to 0, union 0 to 3 by 2, union 3 by 2 to 5. 5 union 8 to infinity, right? Sir, interval will check at 0. 0 is a pole, so open interval, union open interval, 3 by 2 is a zeros, equality symbol is there, so close interval 3 by 2 to 5, and then we are having union 8 to infinity over there likewise, right? But these two can be combined, right? 3 by 2 is included throughout, so directly we can say 0 to 5 also. So accordingly, we can answer it as minus infinity to 0, union 0 to 5 directly, 0 open to close 5, union 8 to infinity. That also we can answer it as. Yes? This is what we are having the solution set of this question. Clear? Okay, next. Sir, you told like you will explain why even powers does not make any changes in the sign. Okay, we'll see. Now tell me, you people tell me, x minus 2 and x minus 3 whole square, let's say we are having, right? Or x minus 5 continuous, x minus 5 whole square. Okay, now you people tell me, let's say if I'm substituting 2 here and 5 here. Okay, now any value above 5, you people let me know, any value above 5, and simultaneously let's say we are having x minus 7 also here, so 7 also I'm plotting. Any value above 7, 8 if I'm taking, okay, 8 if I'm taking, 8 minus 2 positive, 8 minus 5 positive, 8 minus 7 positive, so product will be also positive. So any value above 7 if we are taking, this product will be positive. Any value between 5 and 7, 5 and 7, let's say 6 if I'm taking, 6 minus 2 positive, 6 minus 5 positive, 6 minus 7 negative, so negative into negative into positive will become negative. Okay, any value between 2 to 5 if we are taking, 2 to 5, tell me, 2 to 5, let's say 3 minus 2 positive, 3 minus 5 negative, but square is there, so it will become again positive. 3 minus 7 negative, so positive negative, again it will be negative. Due to this even power, sign does not change. Now let's say if you are taking less than 2, 1 we are taking, negative, positive, negative, negative into negative, positive, again we'll get this result, right? So the moment we are not having star, the next part will be having the different sign over there, right? So accordingly we'll be answering it over here. I hope you are able to understand. Yes, we are already up to the time. Remaining part I'll be taking in the next session. I have added some questions for you. You can take the screenshots. You can prepare the notes accordingly. Yes, sir, 4 minus x square, a square minus b square is a plus b into a minus b. You can use in both the cases over here, right? Likewise, x square minus x minus 1. In this, you try to solve these questions. You can take the screenshot, or else accordingly you can pause the video and write the question accordingly, right? This question we'll discuss in the upcoming sessions. Okay, this question, yes, as I told, I'll add some good questions at the end, so it is there for you. You will be solving these questions. Okay, okay, that is it for the first session, everyone. In the upcoming sessions, we will be dealing with the remaining part, whatever it is left for you, right? Graphs as well as logarithm as well as some basic graphical explanation also will be discussing it over there, right? Yeah, that's it for the day today. Thank you everyone. We'll see you in the next class. Yep.